Hello and welcome back to a new video and a new course, and this time on probability. A fairly easy topic to master. You can do it in a day or two, maybe spend an hour or two on this topic and you will know most of it. 70 to 80% of it you will understand fairly quickly. So our agenda is to try and do that, try and understand the core ideas involved. Let's get started. So first of all, let us start with the probability formula. Even though we might not know the meaning of these terms, but let us just put it out there, and that is a probability of an event is in the numerator I have number of favorable outcomes, and in the denominator I have all possible outcomes. So probability of an event is a numerator by denominator form. It's a fraction, it's a ratio, and in the numerator I put the number of favorable outcomes. In the denominator I put the number of all possible outcomes. So what is the meaning of an event, what is the meaning of all possible outcomes, and what is the meaning of favorable outcome? That is what we need to understand. Heads, heads, tails, 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 heads, heads. So try this out. Try tossing a coin a few times and see for the event of tossing a coin what are the possible outcomes, and that would be fairly easy. Within a minute, less than a minute, you will see that when we are talking about tossing a coin, the number of possible outcomes are two. Either you will get a head or a tail. We're not interested in what the outcome is, we are interested in the number of outcomes. So when we talk about tossing a coin, my total number of outcomes for a single coin are always only going to be two, either a head or a tail. Now let me frame the question and I say, what is the probability of you getting a head when you toss a coin? So now when I look at the question and it says, what is the probability of getting a head, right? I want a head to happen. That means it is favorable for me that head should appear. So that is what we mean by favorable outcome, an outcome that you want to happen. For example, you might be in a bet with someone and you say if head comes, he will give all his property to you. So the head coming is favorable to you. So out of these two events, if I say what is the probability of getting a head, what is the favorable outcome? Head is the favorable outcome, and that is 1 in number. So how many favorable outcomes do I have? I have one favorable outcome. How many all possible outcomes? I have two possible outcomes. So my probability of getting a head is going to be, probability of H is going to be 1 by 2. Where did I get this 2 from? From my two possible outcomes. Where did I get this 1 from? I got it from my favorable outcome. So I hope you're getting the idea of what we mean by an event, what we mean by possible outcomes, and what we mean by favorable outcome. And we're also seeing that this is fairly very straightforward, easy, right? Something goes in the numerator, something goes in the denominator, bang, you have your answer. Just to drive home that idea that probability of an event is number of favorable outcomes divided by all possible outcomes, let's try and use one more example, and this time let's use a die. And I'm sure all of us have played Ludo or Snakes and Ladder, and we have played with such a thing, and we roll it, and we know with a standard die there are 6 possible outcomes. So if I talk about a single die being rolled, what are the number of possible outcomes? You can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. That means you have overall 6 possibilities. Now depending on the question, I can frame the language, right? I say, what is the probability of you getting a 6? So out of these 6 possible outcomes, what is it that you want? What is it that is favorable for you? You want a 6 to come. And how many such events? Only one such event. So once again your answer is going to be 1 is going to go into the numerator and 6 is going to go into the denominator, right? So your answer for your probability of getting a 6 on a roll is going to be 1 by 6. So again, let's take one more example, and this idea will become slightly clearer to us. I say, what is the probability of you not getting a 6? That means out of my 1, 2, 3, 4, 5, 6 events, I do not want 6. That means everything else is favorable to me. How many events are favorable to me now? 1 is also okay, 2 is also okay, 3 is also okay, 4 is also okay, 5 is also okay. How many such events if I count them? 5, right? So now my answer, if I say what is the probability of not getting a 6, your answer is going to be 5 by 6, right? Another thing that you can just notice here or begin to notice here is, if I add the probability of not getting a 6 and getting a 6, once again the answer is always going to be 1, just like we noticed in the previous example. We're not building a theory now, no terms are being introduced, we're just noticing basic stuff. This example can be further extended a little bit. I say I roll a die, and what is the probability that the number is going to be even? You can also stop and think, what is the probability that the number is going to be odd? Once again, what is our probability formula? Favorable outcomes in the numerator and all possible outcomes in the denominator. How many possible outcomes when we talk about a single die? 6 possible outcomes. And what is favorable now to me? He's saying I want an even number. Out of 1, 2, 3, 4, 5, 6, how many are even? I have 2, I have 4, I have 6. So 3 events are favorable to me. So my answer is going to be 3 by 6, which is 1 by 2. So what is the probability of you getting an even number when you roll a die? Your answer is going to be 1 by 2, 0.5 or 50%, right? Okay, so just to repeat this idea of what is the formula for probability, what is the meaning of all possible outcome, what is the meaning of favorable outcome, etc. Let's try one more example, and it is again a standard question. You are asked to draw one card out of a deck of cards, right? So you have a whole new pack of cards, and you're asked to draw one card out of it. What is the probability that it is going to be an ace? So once again, start with your formula. In the denominator, you want all possible outcomes. So now in a deck of cards, you have 52 cards. Now this is not part of the probability theory. This is part of the world theory, general knowledge. We have seen a deck of cards. We've seen other people play cards. We know that there are 52 cards in a deck. If you don't know, I'm telling you right now, in a deck there are 52 cards, or you can buy one and check for yourself. So I'm talking about taking one card out of 52. How many ways can I do it? I can do it 52 different ways. So my number of all possible outcomes in the denominator is going to be 52. So how many possible outcomes? 52 outcomes. Now you want an ace. That is what a favorable outcome for you is, right? If you get an ace, you will win the game or you will win something. So it is favorable for you. Now once again, you have to remember that in a deck of cards, out of these 52 cards, 4 are ace cards, right? So out of these 52 events, so out of these 52 outcomes, how many are favorable for you? 4 are favorable for you. So 52 goes in the denominator, and 4, which is the number of aces, goes in the numerator. So your answer for this would be 4 upon 52, or 1 by 13, right? The question was, what is the probability that when you draw one card, that the card is going to be an ace, right? So 52 possible outcomes and 4 favorable outcomes. My answer is 4 by 52. If I change the logic a little bit and I say, what is the probability that the card is going to be a black card? So once again, I have to think, okay, first of all, in the denominator, my answer is going to be the same because it is 52, the same as earlier. But when we talk about red or black cards, again, I have to remember that in a deck of cards, there are 26 red cards and 26 black cards. So if you want a black card, which is the favorable event for you, you say, okay, out of these 52, 26 are favorable for me. So what is the probability of getting a black card? It is going to be 26 upon 52. Similarly, if I had asked you what is the probability of getting a red card, again the answer would have been 26 by 52 because there are 26 red cards in the pack. So again, you can try out a few more questions related with a pack of cards. It could be, what is the probability that it is a black number card? What is the probability that is going to be a face card? What is the probability that is going to be a black king, etc., etc. But remember, if you're drawing one card, your answer will always have a 52 in the denominator. Just to get you started, if you were to draw two cards, right, your answer in the denominator would be 52 into 51. And the logic for it is very, very simple. When you draw out one card, right, out of 52, you draw out one card. There are 52 ways of doing it. But once you have done that, out of the remaining cards, what are the possible outcomes? 51 outcomes. So 52 into 51 we'll do, or we'll write it as 52C2. These ideas are part of counting theory, and you can learn them better in the permutations and combinations lecture.